To solve a trigonometric equation, we use the rules of algebra to isolate the trigonometric function on one side of the equal sign. Then we use our knowledge of the values of the trigonometric functions to solve for the variable. So if you're not really familiar with all the values for the trigonometric functions, I'd recommend having a unit circle to assist. Now, when there are no intervals given, you have to be mindful of the period of the function you have solved for to find all the solutions that are possible. So what does that mean? It just means that instead of having a specific number of answers, we actually have a general solution, because on the unit circle, wherever you are at, if you add 360 degrees or 2 pi, you will end up right back there. So you can actually have an infinite amount of solutions. So since we don't have an interval stated, we're actually going to write general solutions to these equations. So let's start with the first one. 2 sine x minus 1 equals 0. We're going to start off solving this the same way we've done before. We're going to add 1 over, and then divide the 2 so we can get sine by itself. Now we think, where on the unit circle would sine x equal a half? Well, let's just limit ourselves to one complete revolution of the unit circle from 0 to 2 pi. Sine x would equal 1/2 at 2 spots. X equals pi over 6 and 5 pi over 6. Now that's well and good for just one complete revolution around the unit circle, but if we keep going around and around, like if we start at pi over 6 and add 2 pi, we'd end up right back where we started, and then another 2 pi and another 2 pi and so on. So we could have infinite amount of solutions just ending at where pi over 6 is or 5 pi over 6 is on the unit circle. So what would the general solution be? Well, we know that x equals pi over 6 is a solution. And if I go 2 pi around, I'd end up at the same spot on the unit circle. So I say that pi over 6 plus 2k pi will give me all the general solutions. So if I add, if this is a 1, so pi over 6 plus 2 times 1 times pi would give me the same answer as this. And if I do pi over 6 plus 2 times pi, again I'll get another answer that works. It'd be the same spot as pi over 6. And I have to specify that k must be an integer. So shorthand notation for that is going to look like this. K is an element of integers. That's what this fancy z means. It's just integers. So this is one of the general solutions. The other is 5 pi over 6. So again, x equals 5 pi over 6. And if I add another 2 pi k to that, or 2k pi, I would get back to the same spot. So every time I make k an integer, I would always end up back at the same equivalent spot as 5 pi over 6. And again, I must state that k is an integer. You don't necessarily have to use k. Any letter will technically do, but k is the most common. In any case, these are the two solutions to this equation, the two general solutions. Now what about tangent squared x minus 3 equals 0? Start off the same way. We're going to solve for tangent. Add 3 over, and then square root both sides. I'm going to end up with plus or minus root 3. Now again, let's say I was just looking at one revolution around the unit circle from 0 to 2 pi. I would actually get 4 answers. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But again, I have no interval stated, so I need to find the general solution. Now you have to remember that tangent has a period of pi, and there's also a vertical asymptote at pi over 2, 3 pi over 2, and so on. So I want to take one complete period of tangent, and I know the period of tangent is negative pi over 2 to pi over 2. And since this is the period of tangent, and I know in the unit circle that pi over 3 is in here, but none of these three are, except for this one, kind of. I know that if I start it on the x-axis and go a positive distance, I'm going to go counterclockwise. But if I go a negative radians, I will go clockwise. So 5 pi over 3 is equivalent to negative pi over 3, and that they both end at the same spot on the unit circle. So I'm going to use pi over 3 and negative pi over 3 to make my general solutions. So start off with the first one, the nice one, pi over 3. I know that x equals pi over 3. Now if I added 2 pi to it, I would get back here. But as you can see, I have these 4 solutions. And if I add a pi to this, I'm going to end up at 4 pi over 3. And if I end up another pi to that, I'm going to end up back to the equivalent spot here and add another pi back here. So it can bounce back between these two values on the unit circle. So I don't need to add 2 pi. I can add k pi, where k is an integer. And this would be the general solution for this one, using pi over 3. But I can also use negative pi over 3 because it's in the period. And again, negative pi over 3 is equivalent to where 5 pi over 3 is. And if I add pi to negative pi over 3, I'm going to get 2 pi over 3. Then add another pi, and I'll get to 5 pi over 3. And add another pi, I'll be back to the equivalent spot here, and I'll go back and forth between these two solutions. So again, I can just add another k pi to make it my general solution and state that k is an integer. And these two would be my general solutions for this equation that will account for all solutions for this equation.